think it helps in this sort of question to get a sketch down of what is going on. And it also just helps you learn over time, really quickly what these kind of curves look like. So I know that this graph here is going to go through x equals 7. And then I know it's a negative quadratic, so it's basically going to come down like this. Having said that, I don't know if the turning point is here. So I probably shouldn't assume it. So let's have it going up a little bit more and then back down. It could also be to the left, but let's just make it here for the time being. Now, we're told to find the equation of the tangent at the point where x is equal to 5. So let me say that's here. So I'm looking for a straight line that will just touch at that point, maybe like that. And we're told P is equal to 5. So to get the equation of the tangent, essentially we have to use the fact that the curve and the tangent have the same gradient at P, and they have the same y value. The first thing I'm going to do is work out the y value then. When x equals 5, y is going to be 7 plus 30. I'm just substituting 5 into here, minus 25, which is going to give me 12. So P is 5, 12. Okay, now tangent. Sorry, this is part 1. I think that's why I think it's really good to draw a diagram, because it's kind of, for me now, it's quite clear what is going on. Of course, if you can do it without, like if you follow the steps, just make sure you understand why you're doing it. And but yeah, visual representation is helpful. Tangent and quadratic have same gradient at x equals 5. So we need to find the instantaneous gradient for y equals 7 plus 6x minus x squared. And that is going to be 6 minus 2x. So when x is equal to 5, dy by dx, which is the gradient of the curve and the gradient of the tangent now, is going to equal minus 4. So we've got all the information we need now. For the tangent, I can use y minus y1 is equal to m x minus x1. So y minus 12, I'm now using a pair of coordinates that I know that the line goes through. And I'm going to use the gradient that it has, which I know is now minus 4. And we're asked to write it in the form ax plus by plus c equals 0. So expand it out. And then it's going to be 4. Wait, was it x first? Yeah, so 4x plus y minus 32 equals 0. You could write minus 4x minus y plus 32 equals 0. Both is fine. Okay, but here I've left the x and the y with positive coefficients. All right. Now on to part 2. This tangent meets the x-axis at Q. That's going to be here. Work out the midpoint of PQ. So that's going to be roughly here. So let's find Q. At Q, y is equal to 0. So 4x, I can just let y equal 0 in this tangent equation. 4x minus 32 equals 0, and x equals 8. So we get 8, 0 as Q. We also remember have P as 5, 12. So I want to find the midpoint. That is the middle like it's going to be the middle of the x coordinates and the middle of the y coordinates. And you can do this just by looking at them or by adding them together and dividing by 2. Okay, that's just a nice quick process. So 13 over 2, it's the same as 6.5. 6.5 is 1.5 away from 5 and 1.5 away from 8. And then 6, 12 over 2 is clearly halfway between 0 and 12. Okay, good. We're now asked to find the line of symmetry of this quadratic curve. So, and then state the values where it's increasing. So I'm going to bring my sketch down. I'm actually not interested in the tangent anymore. Okay, now the line of symmetry goes through the minimum points. That's important to know because it is symmetrical about that minimum point. Now, I don't know if it's going to be to the right or to the left. It doesn't matter. My sketch like kind of shows, yeah, my minimum point is here. Sorry, in this case, it's my maximum point, minimum or maximum point. And then it's going to be a vertical line. Now, there's two ways to do this. The first way is, well, both ways involve realizing that it goes through the stationary point. So method 1, it's going to be where dy by dx for the function, which if you remember, actually I've forgotten it, was it 6 minus 2x? Yes. It's going to equal 0 at the stationary point. In this case, it's a maximum. We can solve that to give x is equal to 3, which actually is the equation of the line of symmetry. Okay, a vertical line that goes through x equals 3, that is it. Okay, method 2 is to still use that idea, the fact that we're finding the maximum, but we can complete the square. Now, this is not the best method in this case because it's so quick to use differentiation because we've already have differentiated, but I still want to just do it anyway. Okay, complete the square. So I can take the minus out like you do when you have a number like 2 or 3 in front of the x squared. This time take the minus out. It's going to be x squared minus 6x. And keep the 7 over here. And then complete the square on x squared minus 6x, x minus 3 all squared. This is going to give x squared minus 6x plus 9, so I need to minus a 9. And I'm going to get minus x minus 3 squared plus 9 is going to be plus 16. And what that gives you is the maximum. The maximum is going to be 16 because this thing here is always less than or equal to 0 because that thing there that I'm squaring is always greater or equal to 0. So it can't be any bigger than 16 because I'm always subtracting something essentially. But it can be 16, and that is when this thing would equal 0, which is when x is equal to 3. So that is another way of getting the maximum instead of differentiating. Of course, to get the y value, I'd have to put the x equals 3 back into the original function, and I get 16. But I've found it, that point there. And from that, we see that, okay, again, the line of symmetry is just a vertical line that goes through it, so it must be x equals 3. So a longer route, but worth discussing. The very last bit, state the set of values of x for which this is an increasing function. Okay, now it is increasing as what x increases, y also increases. So it's going to be here. Here it's increasing. Then it temporarily becomes stationary because the gradient is 0 at this point at the maximum before it becomes a decreasing function. So if I know that I've got x equals 3, in fact, I've got 316, or, as long as you've got the x equals 3, that's the important bit, then immediately we see that it's going to be increasing for all values that are less than 3. So we simply get x is less than 3 as our answer. If you don't realize that, then you could resort to looking at dy, where dy by dx, so that, that's fine, we're done, but where dy by dx is greater than 0, and then it would be 6 minus 2x is greater than 0. 6 is greater than 2x. X is less than 3. We can get the answer that way as well, but we don't need to do all of that. If we've got a solid sketch, we understand the graph, then we get it really quickly. So there we go. Quite a lot of little things to do in this question. Well done.